All right, here we go. So just as a review from this morning, so ERDs are entity relational diagrams. So this basically writes our code for us. It generates the SQL code that will create our tables, create our relationships. So wonderful tool. The overview, I'm not going to go into too much of this because we want to get started. So we talked about one-to-one. And what did we say about one-to-one relationships?
Has to be only like one piece of information going to another.
Yeah. So, and they're also not very commonly used. In terms of real life applications, I can only think of like two actual one-to-one relationships that exist between things. And a social security number, and oh yeah, we said fingerprints and stuff like that. So it's very rare to have an actual one-to-one relationship. So I said, you're not going to need it. You're not going to be tested on it. So but we will need to understand one-to-many. Okay, so just to reiterate, we have customers. We separated them into addresses, but a customer can have many orders, right? So, and we said that Michael Choi has 2 orders, right? Because he's listed twice down here. And then we established a relationship with the foreign key. So now we need to talk about many-to-many. So many-to-many, so if we have orders and we have items, this is an example of a many-to-many relationship. Okay, so an order can have many items, and items can be part of many orders. Okay, so and then anytime we want to create a many-to-many relationship, we have to have what's called a join table. Okay, so this is the only way to create a many-to-many relationship. And basically, the item orders, we don't have to call it by that. That's convention to just basically concatenate the 2 names or the 2 table names, but we can call it whatever is relevant. And we can also keep track of data about the relationship in this table. Okay, so if we have likes, right? Likes is a common example of something where there's a many-to-many. All right, questions about many-to-many?
Not right now.
Okay.
I might maybe later when I'm.
Oh, they'll be coming. I get it. Okay. All right. So again, they can be confusing. So the best thing to do is to just talk out the relationships that exist, and we ultimately decide whether or not we want a many-to-many relationship or a one-to-many relationship. And you have to have a connector table, also known as a join table. All right, and I'm going to probably do a demo on many-to-many just so everybody gets more comfortable with them. All right, so normalization. Let me just do something real fast. There we go. Okay, so from the reading, can anybody tell me what normalization is?
There's like 3 rules that they want you to follow, right?
Yes, the 3 forms. Right. So, and I took this again. This is a direct quote from the platform because I couldn't have said it better, basically. So database normalization is simply a convention, excuse me, of splitting large tables of data into smaller separate tables. And the primary goal is we don't want to repeat data. Okay. Now, this comes with a big warning. It's possible to take normalization to an extreme, right? So these are guidelines rather than hard and fast rules. Pardon me. So the 3 forms are basically these. So they're cumulative, meaning you have to have form 1 before you can have form 2. You have to have form 2 before you can have form 3. So the first form is the simplest way I can boil it down is 1 column, 1 value. So given that, would this table, this example, be compliant with the first form, the first normalization form?
No,
No, why not?
because the addresses are messed up. They got more than that
Exactly.
need to be divided.
One column, one value. So we should have basically this. We should have, and breaking it into another table is optional, but we want our street separated. And you can even go further, right? You could say, okay, street number in one table, the street, and then, you know, any, what do they call it? Like lane or drive, like sub postfix, whatever. So again, it's possible to take this to extremes, but you want, for the most part, one column or one value per column. Okay, questions about the first form?
Would there be like any disadvantage of just having like all that information in the same column, like with the first name, last name, but then just go like first name, last name instead of address, go like street, city, state?
Yeah. And so that's what I was talking about with the one-to-one relationship, how uncommon it is. Yeah, this basically moving, oops. Like having this go here, right? Just like moving this up here and then scrapping this would be fine. Yeah, that, because unless we have something where having a separate address table is beneficial for us, you know, for most, I think, of our applications, we could just put these two tables together. Just put the first last name with the addresses and it would be fine. You don't need to go to the trouble of creating a separate address table. Yeah. Cool. All right, so that's the first form. The second form is each column should have a unique value. Okay, so except for keys. So obviously we're going to have, like, if we have a foreign key, we're going to have duplicate values in the key tables, but the idea is you should have one. So you shouldn't have, I'm sorry, each column should have a unique value. But again, this can be taken to an extreme, right? So we have here at the bottom here, we have a two Michael Choi's, right? So it's kind of silly to say, well, now we need a Michael Choi table, right? Because his name is repeated twice. So this can be, you kind of have to use common sense, logic, and you don't want to make tables out forever, right? So use your best judgment, and you want to try to have unique values, but if you'd have some duplication, it's not the end of the world. Okay, does that make sense? Any questions about the second form? All right.
What do you mean by keys?
Yes, cool. Good question. So keys are like foreign keys and primary keys. So if we have, if we want to establish a relationship between two entities, it's okay to have duplicate, duplicate foreign keys on a table. So this is perfectly acceptable, right? Having twos, that's just establishing a relationship. So having multiple keys, and this is fine as well, right? Because we're establishing a relationship. So the forms, the second form and the third form don't apply to keys at all. So meaning primary keys or foreign keys. Okay. Any other questions? All right. So the third form is no column should depend on another. And again, this one is hard to achieve because, I mean, you could, I mean, that's just, I think, impossible to achieve, right? Because you could say that the address 576 Steel Lane, Grass Valley, New York, depends on Randall Frisk, right? Because that's his address. So having, I think probably the best example of the third form is if we have a table and we're keeping track of people's birthdays, right? For some reason, like we're Chuck E. Cheese or whatever. We would not have a table for birthday and for age, right? We would keep their birthday because we could always use Python or even SQL to derive their age from their birthday, right? So that would be an example of a good example, and the best one I can think of for third form. You don't want to have one table depending on another, meaning if you don't want to store data that you don't need to store. Okay, makes sense? Questions about that? So conventions. So the conventions, we talked a little bit about this morning when I did the demonstration. So users, well, when we make a table, we use plural and lowercase names. Okay, so examples would be users, sites, clients. And we use ID as the primary key, meaning we don't say user's ID or client's ID. We just, the name of the ID or the primary key on every table is just ID. And we use the same process every time, primary key, not null, and then auto increment. Okay, so that's just the procedure we're following. And I think these conventions are pretty widespread. This, I think, is a good representation of how it's done. Different companies will have different procedures, and you may work for a company that does things differently, but that's fine. We're following this so everybody's on the same page. And then when we create foreign keys, we delete the S, right? So we're always going to go through, and our foreign keys will be singular versions of the table they're connecting to. Okay, so for instance, we have a users table. We would, if we want to connect users to that table, we would say, so users, and then we would say user ID. So when we do the auto generating using ERD or MySQL Workbench, we just cut off the S. Same with sites and clients. We just we're connecting to the sites table. We call it site ID, client ID. And then finally, every single table we make, whether it's a relationship, a physical object, a bank account, a user, whatever, we're always going to include a created at and an updated at. Okay, just because it's valuable data to have. Okay, any questions on the conventions? All right. Okay, finally, data types. So the data types we're going to use, data types is basically the types of data we're going to use to store, the types we're going to use to store our data. So primarily the one you're going to use most often is varchar or varchar. It can hold up to 255 characters. And this one stores a variable number of characters. So if we specify varchar 45 and the person only types in 5, it will only store those 5 characters. Okay, it won't make space for 45. On the other hand, char will take up all the space. So if we say char 45 and the user types in 5 characters, char is going to make space for 45 characters. Okay, so this is varchar or varchar is more efficient, a more efficient way of storing string data. Int is up to this huge number, 4 billion something. It can be signed or unsigned. If we use a signed version, you basically cut this number in half because half of them go to the negative side, half of them go to the positive side. But primarily, I think for ints, we use ints for IDs, so we don't need to worry about that. We can basically store 4 billion pieces of information without running out of IDs. But we need more space. There's big int, which will store up to, I don't even know what number that is. Yeah, that one, the 18 with that huge number. So Facebook might need this one, right? Because I think they have 2 billion users. So at some point in history, at some point in the future, they may need this one. We also have tiny int. And again, this is just more efficient way. So if we only wanted to, like if we wanted to keep track of a level for some reason, like if a user was at a certain level, we could use tiny int. That way we don't need to have the space for 4 billion digits. If we're only like keeping track of zero, like a users at 1 through 9, we could use a tiny int for that. We also use tiny int for Booleans. If we wanted to store true or false, 0 or 1, tiny int, we could, that's another use for tiny int. And float, just like floating points in programming language, if we want to use a decimal point, if we want to keep track of money or anything that has a fractional value, we use the float. Text is for anything that's larger than 255 characters. I can't remember the maximum for text, but it's a lot. So if varchar isn't big enough, if we need more than 255 characters, so if like we wanted to store like a blog entry or something like that, we would use text, the text data type. And finally, there's a date and a date time. Date time will store the date as well as the time. So if you only want to store like a birthday, it's kind of creepy to store like a person's birth time, right? You would use date. But for timestamps, we want to use this because we have up to the second of when something happened. Tyree.
So for the text, would that like, if there was like a blog entry or something, would that all just go in like one of the rows of like the data table? Or like,
Well, yeah. Yeah, I mean, it might store it in, I think it does, because unless you specify there's a binary data type. So if you wanted to store like images or something like that, you would use a data type called blob, which I can't remember what I think it's binary large object. So if you wanted to store something like an image or binary text, like bit files or something like that, like executable code, you would use the binary. So yeah, I think it just stores the raw text in the table. Yeah.
interesting. All right, thank you.
Yeah. Any other questions about the data types? Okay. All right. So I want to do a demo on many-to-many. So let me get out of this. Okay, so the friendships one, let's just do like I'll talk, so if you've tried the friendships one, I think this is probably one of the more difficult and confusing assignments. This will make sense when we talk about joins tomorrow. So if you've tried this and had issues with it, it will make more sense when we talk about joins and left joins tomorrow. But I want to demonstrate making a many-to-many relationship. So let me go into SQL Workbench. Put this here. So if I want to make an ERD, where do I start?
You go down one, right?
Yeah. So this is the database. Again, these are the databases. This is the terrain. This is the map, right? So we're going to start with the map. So I'm going to click here. If I want to make a new model, I just click the plus sign. And we can use this to generate our model. So what many-to-many relationship should I make? Does anybody think of a many-to-many relationship that you'd like to see me model?
Like comments or replies or something?
Yeah. So we'll call it
Feedback.
What is it?
Call it feedback because
Feedback. Okay. Feedback. Okay. Oops. So I think that saves my schema. So now once I've renamed now, and schema and database are used interchangeably. So I can have a feedback database and not necessarily have a feedback table, right? That's just what I've called the database or the schema. So now how do I add an ERD diagram?
Yeah, add diagram up there.
Yeah. Right. So now once I've renamed my schema, click on add diagram. Okay, and that brings me into here. So if I want to create a table, I click right here and add a table. So we're going to need two. Well, actually, we're going to need three because anytime you make a many-to-many, you have to have the join. Tim.
So for each project, are we creating a new schema or are we creating just one schema with several EER diagrams? I'm guessing a schema per project.
Good question. Yeah. So just like with how we make a brand new Flask application every time, we're going to make a separate database for each individual project we do. So you're not going to have like one database that handles like your users and your books and your friendships and all that. So each time we're going to create a new database.
And then I guess a follow-up question is like, would we often need to create more than one EER diagram per schema?
Oh, yes. So no, the ERD diagram, which is redundant, but yeah, you're only going to make one. You can have multiple tables, but that's a single database is just going to be one ERD diagram.
Okay. Thanks.
Okay, so let's say what should our first one be? Let's do users because I want to kind of drive that home. So I'm going to make a user. And I say my primary key is always ID. It's always an int. And I always want to auto increment, right? So the next one, I'm going to say my user has a name. And I'm not going to be lazy. I'm going to do the whole thing. So I'm going to say first name and leave the varchar at 45. Last name, varchar is 45 is fine. Email and password. Okay, what do I need to change when I make a password?
Were these the ones that you were saying you didn't want to be plural? Like you said, the tables were plural, right? And then some of them, which ones weren't supposed to be pluralized?
So these are just my parameters for my object, right? So
Alright.
have a person, he's got a first name, he, she has a first name, last name, email, right? So if I do a join, right? If I create a foreign key, has to be singular. So
Okay.
the foreign keys have to be singular, but the table name has to be plural.
Okay.
Okay, so I want to create a password. What do I need to change?
To 255, right?
Yeah.
25.
45 will not be enough space for our hash password. So always change the varchar to 255. And what are the two columns? Wait, yeah, two columns we have to have on every single table.
Created at and updated at.
Created at and updated at. So created at, and anybody remember the data type?
Date time.
Date time. And to get the timestamp, we need to add the default expression now. And we need a created at, I'm sorry, updated at. Oops. Updated at. Same data type, date, time. And then what do I write here? Anybody remember?
So now with the parentheses again, then isn't it like update time now or something like that?
Now on update. Now.
Yeah.
So what does the now parentheses up top do again?
So the now is
function.
a function within MySQL that will just generate the current time. So whatever time this, any time or whatever time a user is created, it's just going to timestamp it and assign it to the created at column. The now, so when a user is first created at and updated at are going to be equivalent, right? Because they're made in the same time. So these two now statements will run. So oops, I'll move it. So this now will run, that now will run. So if I update my user, if I change the password, change the last name or whatever, when that changes, it's going to reassign my updated at to whatever time the update occurs.
Okay.
And so if there's 10 updates, my updated at will be the time that the final update or most recent update happened.
Got you, leaving the created at variable to times whatever it is.
And the on update just tells us, okay, so when we first make it, we want it to be this. If it's updated, right? We're not going to update everything, but if we have a element that needs to be updated, if that happens, then reapply, like give it a new timestamp. All right.
Okay, thanks.
Any other questions? All right. So let me close this. All right, so we have users, and what is the user going to have many of? And then the thing we're making also has many users.
Comments. Because the user can make a bunch of comments and the comments can have a bunch of users that are, writing stuff on it.
Will that work?
Are you trying to do many to many?
Yeah.
Users and products, maybe?
Users and accounts, perhaps, like
Users.
different social media accounts and user.
I'm kind of liking the products idea.
Because you can like buy a
Right.
bunch of stuff, but then a bunch of stuff can
Yeah.
get bought by different people.
So a user will have many products and a product will have many users. Okay, I like it. Doesn't really matter, right? We're just doing it as a demonstration. So I'm going to call my table 2 products. Has to have an ID, right? Called ID. Has to be an int. Has to be primary key. Has to be not null. Has to auto increment. And the product is going to have just a description. And I'll just keep the regular varchar, so description. And it's going to be created at thank you. Okay, thank you, Annie. Sorry about that. So created at, and so date time, right? And the created at has to be now. And updated at is also date time. Oops, it went away. Date time. And now on update now. Oops. Cool. All right, so now we have our user and we have our product. We have a third table in here, and we're going to use this to create the relationship. Okay, so the same way we did with a one-to-many, we're going to do the same procedure, right? But the many relationships are going to go to the table in the middle. Okay, so we're going to start with the many and go to the one. And basically, we're just making two symmetrical two symmetrical one-to-many relationships on each of these. Okay, so I'm going to click on, always use the dashed line. Okay, so I'm going to start with the many, go to the table 3. Why didn't that do it? What did I do? Oh, you know what? I think I have to have an ID on this one, and it has to have a name. So I'm going to say user products. Column is going to be ID. And auto increment. And you know what? I'm going to add. Yeah, I'm going to do it. Created at. Big time now. Updated at. Date time. And now on update now.
So this is how we would do a many to many,
Yes.
because the platform was trying to show us something different
Really?
from what I was reading and what I did. They wanted us to use the what is it, that icon second from the bottom with the 2 crow's feet on both sides.
This one?
Yeah, that's what I saw at least.
Yeah, I saw that too.
Where'd you see that?
It's in the video.
Yeah, it's in the video on, I think it's the friendships one. Or it's either the, yeah, I think it's the friendships. It's either the friendships or the one before the friendships.
The books?
So what the platform is showing you is basically the same, almost the same thing. The thing is, what Tyler is showing allows us to do the create and update in the middle table. So it's the same thing, ultimately. At the end of the day, it's just what Tyler is doing allows us to add more information to the middle table.
Oh, okay.
And it doesn't necessitate so the solid lines, let me go back. So the solid lines mean that it's an identifying relationship, meaning you have to have one in order to have the other. So if we wanted to have a user that didn't have many products, we wouldn't be able to do it if we had the solid line. Does that make sense?
Yes.
Okay. All right, so let me try this again. So we go to start at the many, go to products. So products has many users and users has many products. I did that wrong, sorry. I did those both wrong, sorry. Delete, there we go. Delete.
So anytime we do a many to many, we should just do it this way instead.
I would, I think, because I think this makes it much easier. It makes it easier to add data, makes it easier to, like if we wanted to put data on the middle table. So if we wanted to add some sort of attribute to the relationship, like if we wanted to, like if we had likes, right, as a join, we wouldn't be able to add data if it were, if we use the solid.
Okay.
Let me do this again. I did this wrong the first time, so let me do it right this time. Okay, cool. So this is the many. There we go. Cool. Okay, so am I done?
No.
Why not?
Yep. In the middle table, you have to change the bottom two columns to where it's just singular instead of plural.
Outstanding, right? So anytime, any foreign keys we have, and we're just following this convention, we're going to take the S and make the foreign key be the similar version of the product of the table we're joining.
That got added because you did the crow's feet thing, right?
Yes.
Like they put it at the bottom there?
Yes,
Okay.
exactly. So as soon as I drew that line, as soon as I made that line, we could see those are auto-populated, but we're following the convention. Oh my God, go away. So yeah, as soon as I did that, the crow's feet say that, okay, this has many, like the crow's feet goes towards the many. So it's saying, I want to keep track of the users and the products or the relationship between them. Okay, so question so far. Okay. I kind of want to show the relationship. So I'm going to do something that we're going to get into this tomorrow. But I just want to show you how to go from this to the database. So to make the database from our ERD, you just go to database, go to forward engineer, and there's a bunch of pop-ups that come up. You can just select the defaults. If you wanted to, if I had a database already called, what I call this, feedback, then I could say generate drop schema and it would drop the database that I already have, but I'm not going to do that. And I need to type in my password.
Hey, Tyler, real quick, on the first page on connection options.
Hold on 1 second. Let me go back here.
Connection options. Yeah.
Yeah.
Also, okay, because mine on stored connection, it didn't say local, so I just selected it right now. Okay. All right.
Oh, up here it doesn't say localhost instance.
No, it was just blank, but it's in the selections, but yeah.
Okay. I'm not sure what that does. Ed, do you know what that is? What that does?
Which one?
The stored connection, that's just the connection to the server, right?
Oh, I think that's just the name for the square. Like you can create like different connections, but yeah,
Oh.
that's
Okay, so I think it doesn't matter if it's blank, right? Because I think I've seen it blank before.
yeah. I think all it does is if you go home, that's the square name that it's gonna get saved to.
Gotcha. Okay.
Yeah.
Okay.
So I could have left it. I could have left it blank then.
You could have, but I mean, I think that's fine. It doesn't really, I don't think it makes a difference.
Okay.
Okay, so if I click next, and again, if you want to drop, if I had a feedback table that I wanted to re-engineer, I could just say generate drop schema, but I would lose all the data that's in that table. Okay, so if I click next, type in the root, you can add this to your keychain. Just say save password in Vault. That way you don't have to keep typing it. I do it just to I don't know, just to show you with the steps. And then click next. Okay, so this is all of the SQL that was generated by making this little chart. Okay, so by clicking the boxes, dragging little arrows back and forth, it generated all of this. So I think the ERD is easier. That's just my opinion. So, but if you wanted to save this, if you want to like regenerate this on somebody else's machine, you can save it to a file, you can copy it to your clipboard, you paste it into a SQL editor and run it, it'll just generate the tables that I made. Okay, so I click next, click close. Now, if I come back here to my home and I go from the map to the territory, I go actually to the database, click on my local instance, and see, I don't see it. I'm gonna have to refresh. There it is. So now I have a feedback database with these two. So I have a products table and I have a users table, and then I have the connection between them. Okay.
That's where you can put it on all the like data and stuff. Right?
Yeah, so here I can add data. So if I wanted to add a user, I can form editor. So I can, the ID will auto increment all this stuff. No, I'm using your products. I want to make a user form data. There we go. So I'm going to say Tyler Max, email is tm@email. What else was there? Password. Okay, so now if I come down here and I click apply, the cool thing is it'll give you the SQL that will create the user. So I don't know, I think that's kind of cool. So if you ever forget how to add a user, you can just come in here, add a user with the form, and it'll give you the SQL you need to generate, to add that user. Okay, click apply, finish. Now, if I come back to my users, I'm in the database. Okay.
Password isn't going to be blanked out or anything? Or is that just because it was a name or whatever?
Yeah, so this would normally I would hash it. I'm just
Okay.
And yeah, so do as I say, not as I do. Never, ever, ever do this. Never store a bare text password. This is just for demonstration purposes only. Public service announcement. Don't try this at home, right? This is just for you would never, ever, ever do this. Okay, so if I want to make a product, I can come in here and do the same thing. Description is, I don't know, iPhone. And apply gives me the SQL. Click apply, finish. So now if I want to associate the two, I take oops. I take the ID for the phone, the ID for my user, and connect them. So if I go to user products, I can create. So the user ID is 1. Oops. Product ID is 1. And apply. Finish. So now I have the relationship between the two. So I show that I'm the user and I have a product, and basically the product has me, right? So there's that's generating the connection between the two. Questions? Okay, if it's not crystal clear at this point, it will be once we actually start tomorrow when we actually run the queries and we're doing the joins. This will be more clear once we actually try to associate data and retrieve data. All right, so let me stop sharing.